Okay, so we're going to talk about surface area. So I'm going to briefly go through the process of thinking about how to find the surface area of all of these shapes, and then you'll have time to kind of practice and work through the problems on your own or in groups. So we're first going to talk about the surface area in general. The surface area of a solid is the sum of all the areas of all the faces or surfaces that enclose the solid. So we want all the faces, all the pieces that are on the outside. So we're thinking about how much wrapping paper we need to wrap a Christmas present. So when we're thinking about a prism, we know that we have two bases. We have this base at the very top, we have a base at the bottom, so we need to take both of those into account. And then we need to take care of the entire outside. Now you could break it down and you could think about the sum of all the faces, so the two bases plus the four sides, whereas I kind of like to think about it as the two bases, and then almost like we did volume, thinking about the perimeter, and if I just raise the perimeter up, it's going to cover all of those sides. So when I think about surface area of a prism, and I'm going to use SA as surface area, that's equal to two bases plus the perimeter times the height. So thinking about putting your hands around the shape and then finding the perimeter of that and then raising it all the way up to the top. So B is going to be the area of the base, which is the same as before. And then this time we just have two of them. We have P, which is the perimeter of the base. And then we also have the H, which is the height of the prism. So that's the underlying idea of what we're trying to do here. So take a second, if you want to work through these, or if you want to move on to the next and come back, you can. Okay, so I went ahead and solved these so you could see what I meant by surface area. So I found the bases of them all, I found the perimeters of the bases, and then I was able to find the surface area. And notice that surface area is squared and not cubed like volume. It's also not singular either. So we're dealing with 120 inches squared versus inches or inches cubed. Okay, so moving on to the next idea is cylinders. So cylinders very similar to prisms, except we're dealing with the bases being circles again. If you were to open it up, we did this in class, if you were to open it up, you would have two circles and you would have a rectangle that contains those. So that, if you're thinking about what's happening, is this rectangle would wrap all the way around the entire circle. So the length here of this rectangle is 2 pi r, whatever the radius was, because it's equivalent to the circumference, because it had to wrap all the way around. And then the height of it is just h. So you could think about this as the area of two circles and the rectangle, or because you know the area of this is 2 pi rh, or you could think about it as the two bases plus the circumference, right, or perimeter of the cylinder. So surface area here we know is going to be two bases plus the perimeter times the height, the same idea, except instead of perimeter we're using circumference. So I'll put a C there. So our surface area would be 2 pi r squared, because the area of the base is pi r squared, it's a circle, plus circumference, which is 2 pi r. It's easier to use radius in both places, just because the diameter is not used in other places. So 2 pi r h, which is actually what we found right here, which was the area of that rectangle. So again, up here, B is that area of the base. We have C is the circumference of the circle, and then H is the height of the cylinder. So if you want to go ahead and work on these two problems and see what you come up with. So we did these two problems. I just substituted in what I knew and solved for surface area for the first one, and then the second one I was solving for the height. And so since this was a decimal, I made them all decimals. So I knew that this number here had to be subtracted from 582, and then I could divide by 40.8, and that would give me my 7.755. Okay, so pyramids are a little bit different. They have a different shape, obviously. So surface area of a pyramid, the surface area is the area of the base. So we just have one base here, whereas a prism we had two. And we have the triangular faces. And the height of the triangular faces, we call this the slant height. And we use the variable L in cursive to denote that. And it's very easy for us to make an L look like a 1. So we always want to use that cursive L. We also have this here. We're going to call this S for our side length. And so when we talk about the surface area of a pyramid, I find it easier to think about it as one base plus however many faces we have, right? Provided that we have a regular base. So if base is regular, so all the sides would have to be the same. The surface area is equal to the base, plus all of these side lengths are the same. So I would have however many faces, so it could change. I might have 6, I might have 10, I might have 4. So however many faces I have, and then a face here is a triangle. So if I want to find the area of the triangle, we know that this is S and this is L. So I know that the area of that is half SL. So I like to think of it this way. You can think of it however you want. Again, B is area of the base. F is the number of faces, excluding the base, because that's not a face, that's a base. And then S is your side length of the base, and L is your slant height. So go ahead and try these next two and see if you're able to apply that formula. Okay, so I went ahead and did these two. The first one, keeping in mind too that however many sides you have to your base is how many faces you're going to have. So kind of something to keep in mind. I was able to solve it, and then for this one you had to find the apothem here, or the apothem, in order for you to be able to find the area of the base. And then I had 6 sides, so I have 6 faces besides the base, and so I was able to calculate this. And one thing to note is that this second line of surface area is exact because it has 150 root 3 in it. And so the decimal one is approximate. Even if you give more decimal points, it's still only approximate. Okay, and so the last shape we're looking at is a cone. So to find the surface area of a cone, we want to find the area of the base and add it to that sector of a circle. So this here would have my whole sector. We're not going to use S, so go ahead and cross that off. We use L because L is our slant height. So just like for a pyramid, this is your slant height, and it's the same thing of a cone. And so if you open this up, and we saw that, if you open it up, it makes this little shape here, and this is what goes around and makes this part here. So a cone actually has 2 radii, and it can get kind of confusing because we have the radius of the base, and then when you open the cone, you have a radius which turns into the slant height, and those are the same thing there. So you have a radius of the base, and then you have the slant height, which is the radius of the bigger circle. So if you were to make this a really, really big circle, you would see that this is the center right there, and then it would open up, and this would be the radius of that circle. So to figure out what our formula is for surface area, we know that the surface area has to be the base plus the area of that sector. And so let's figure out what the area of the sector is. So let's just get kind of generic. So I have the area of a sector is to the area of the whole circle, and that would be equal to L, which is this guy right here. No, not L. It should be, so it's S is to C, and I'll explain what S is in a second. So this is arc length right here. This is S. S is for arc length. That's why we weren't using S earlier. S is for arc length. This is going all the way around the base. So this is equal to 2 pi r, because that's the radius of our base here, and so it's the circumference of that entire base is what this forms into. So S is 2 pi r, and again, C is circumference. So we know that circumference is 2 pi L for this whole circle, because the radius now is L instead of r. So we want to solve for the area of the sector in terms of all these variables. So the area of the circle would be pi L squared. So pi L squared. S was 2 pi r, and the circumference is 2 pi L. Now I can see right away that the 2's and the pi's will go away, they become 1. And then I can multiply this over, so I can get area of the sector alone. So I get pi L squared r over L. And so I can reduce those, so the squared and the L will go away. And so all I'm left with is the area of the sector to be pi RL. So I can take that and I can add it over here. So the surface area is the base, which is this guy right here, pi r squared, plus that area of the sector, which we found to be pi RL, or like Pearl. I'm not too worried about finding the area of a sector with degrees right now. If you want to try it, I'll fill it in. You can, but it's not really the most important thing. What I'm looking for is that we're able to use this formula to find the surface area of these cones. So here are the solutions that I got for these problems. I really just looked at what the radius was, if I could find the slant height. 2 of these at the bottom were Pythagorean triples, or you could use the Pythagorean theorem to solve, and you were able to get your answer. So maybe you take a second, write a cheat sheet of all of your surface area formulas and volume formulas, and then go ahead and get started on your homework. Have a great day.